how to set up the system. How can you methodically go through and set up your system and improve the chances of making successful measurements. There's a lot of things that you have to be careful with, just like in any measurement technique. And I'll try to highlight some of those things that are relative specifically to tomographic PIV. Just a rough outline. I'll go over basic requirements of a system. When can you apply a system to what types of flows? Typical configurations, including a discussion about different types of configurations we've seen, plus comment on you're not restricted to any particular configuration. How you mount your cameras and position them. The shine fluid criterion, which anytime you're looking off axis, you have to account for the shine fluid angle. Initial calibration. Discussion about different types of illumination and quantifying energy flux. Most common question we get is how big a volume can you measure in? And energy flux is a big contributor to that. Talk about flow seeding. This is also a very important topic that you have to pay attention to. And then I'll give a little summary and some best practices based on our experience. So Cal already touched on this a little bit, but what are the basic requirements of making three-dimensional measurements using tomographic PIV? And you need at least 3 different non-collinear camera viewing angles so that we have enough information to properly define the position of the particles within the volume and to be able to reconstruct it. Of course, all cameras have to be able to see into the flow field, not being blocked by any object that's in your flow field. So for instance, if you have an airfoil or some other object, you have to arrange your camera so that all cameras can see the flow field of interest. Now, what we recommend for a typical setup is using at least 4 cameras or more, if you're fortunate enough to have enough cameras laying around. Cameras can be really anything. They can be CCDs for conventional frame rates or CMOS cameras for high frame rate systems. Using more cameras allows you to increase the measurement volume size and or your seeding density. And I'll talk about the importance of these later on, of why can't you just take 3 cameras, 4 cameras, and look at any volume, any seeding density that you wish. There are limitations to the system. And if you have a 2D system or a stereo system and you're making successful measurements, more often than not, a tomograph, you could upgrade that to a tomographic system. There's no limitations other than having optical access to your flow field. And by upgrading the system, it's a matter of adding really